more practice test. Oh, what's that? Be pretty easy for you guys. You don't have to graph it. It has to graph, but it's just where they intersect right here. So that is over 3 up 1. So 3, 1 is your ordered pair for that one. Solution for this system. Hopefully it's pretty obvious, but they are parallel. Since they are parallel, it is no solution. They never intersect, so it is no solution. Number 3 says solve the following system or solve the system. It doesn't tell you what to use, so if you want to use elimination or graphing, you can, but it's set up really nicely for substitution because I have one of them where the y is all by itself or where a variable is all by itself. It doesn't have to be the y, it could be the x. I'm taking the 2x plus 3 and I'm plugging it in for that y. So I have negative 2x plus, and instead of y now, I have 2x plus 3 equal to 8. I always use parentheses. In this case, you don't actually need them, but again, as soon as you don't use them, it seems to be the time you should. 2x minus, or sorry, negative 2x plus 2x actually cancels, so we're left with 3 is equal to 8. So just like before, if all our variables cancel, we don't have any variables left, we know something's fishy. It's either it's either infinitely many solutions or no solution. Since this one is false, 3 is not actually equal to 8, this one is no solution. Number 4. So again, you could use substitution, elimination. I would probably not use graphing for this one, but if you want to, you could. If you use 8y to both sides, I think instead this one's enough work. It's almost where the x is by itself. All you have to do is divide everything by 2. So we get x is equal to 18 minus 4y. So if I take that and plug it in for this x, I have 3 multiplied by 18 minus 4y. Minus y is equal to negative 11. 3 times 18 is 54. 12y minus y is equal to negative 11. Negative 12 minus 1 is negative 13y. And now we have a two-step equation. So subtract 54. I get negative 13y is equal to negative 11 minus 54 is negative 65. If you divide that 65 by negative 13, you end up getting y is equal to 5. But once you get y is equal to 5, we still need our s. So now take that, plug it back in. Doesn't matter which equation you plug it in for, but I'm going to say the easiest is going to be this new one you made. So x is equal to 18 minus 4 times 5. That's 18 minus 20. 18 minus 20 is negative 2. So your x is negative 2, your y is 5. If you leave it like that, that's fine, or you could write it as an ordered pair. Remember, multiple choice will be as an ordered pair. And again, you could use elimination with that one as well. Whoops, scroll down too far. So the next two looks like they're set up pretty well for elimination. They're open standard form, so that's what I would recommend using for this one. So let's see. It cancels really nicely, so I guess I'll cancel the y's, but the only reason I choose those instead of the x's is because we have one positive and one negative. But again, that's not much different. So I'm going to multiply the top one by 4. X plus 12y is equal to 100. The bottom one, I'm going to multiply by y is equal to negative 66. My y's cancel. 9 is 17x is equal to 100 minus 66 is 34. Divide by 17, you get your x is equal to 2. Once you have x is equal to 2, sorry, I was going to check my answer to this last one. Once you have your x, your y, it doesn't matter which one you plug it in for. So I'm going to plug it into the first one. Why not? 3y is equal to 25. That's 4 plus 3y is equal to 25. By both sides, 3, y is equal to 7. So again, if you want to leave that, you can. That's probably what I would do because I'm pretty lazy. But you can also, or I guess, also make sure you realize on multiple choice, it's going to be as an ordered pair. So we are with elimination with this one as well. So I'm going to multiply the top one by 3. That gives me 6x plus 15y is equal to 24. The bottom one is negative 6x minus 15y is equal to negative 24. So when we combine these and we put these together, you might already see what's going to happen. The x's and the y's cancel, so we have 0 is equal to 24 minus 24 is 0. 0 is equal to 0. So all our variables canceled, so the red flag should go up, just like in this one. But this is true. 0 is equal to 0. So this one is, it's not all real numbers. It's infinitely many solutions. So I usually just say infinity solution. Number 2, y is x is y is equal to. Circle which ones are solutions. So all I do is find ordered pairs, and if they're in the shaded region, they are a solution. If they're not, they're not. Now, it does get a little more complicated when they're right on the line, and we'll talk about that when we. So negative 1 is negative 2, negative 1 would be right here. Negative 4, positive 2 right here. It's definitely not even close to the shaded region. Region is this blue. 1, 3, so we go over 1 up 3. That's right in the middle, so that is a solution. Negative 2 up 1, 2, 3. So this one is right where they intersect. So actually, that 2 as well. Arrow to it. Negative 6, 5 is way up here and not even close to the. Two up 5. So it's right on the line of the shaded region. So it's right next to the shaded region. It's on the outside edge, but it's right on the line. So if it is or is not a solution, it's determined not whether it's on the line or not, if it's the line is a dotted line or not. If it's a solid line, then it is a solution. If it's on the perimeter of your shaded region, that is a solution. Not. And so that's why, oh no, never mind, I'll go back. Over 5, up 1 is definitely in the shaded region. And 6, negative 1. So 6, negative 1 is right on your line, but this line is dotted. So that's the difference between dotted and solid. Dotted means if it's right on the line, it's still not a solution. Solid means if it's right on that line, it still is a solution. So if you go back to negative 2, 3, that's right where dotted and solid cross. Now remember what it means. Remember, we're trying to find if an inequality, we want it to be a solution for both equations. Well, a solid line is a solution. If it's right on a solid line, it is a solution. So it would be a solution for this equation, but it's a dotted line. That other line. So that I want to talk negative 4, 2 is right here. That is right on a solid line, but it's not on the perimeter. It's not on the edges of my shaded region. So that's why that's still not a solution. So 2, 1, 2, 3. And so I would put it so for, excuse me, you, if you want to, by all means. But if you don't know what that method is, might as well go with divide by negative other over 3x minus 1, 2, 3. Aren't sure if it's correct. We can look at so this one is no solution. Or a little less time consuming is a better way to put it. Y-intercept. My y-intercept is not negative 4, it's 4. I go the other way as well. Down 1 over 2, down 1 over 2. Line. The other one, x is equal to 2, is right here. Remember, if x is equal to is a vertical line. So that vertical line over 2. And shading and dot. For 2. So now there's this one you should this would be on this. Arrows to remind myself I'm shading above that. If you want to put above. Um, three, I get y then I be divided by negative, so it's the same as always. Four, 3. This one is y by itself, span, so we see below. So the overlap above the blue, below the red is everything in this range here. We have y-intercept is 2. I go up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So that is a dotted line. The other one is y is equal to negative 2. That is a horizontal line. And then the shading. Oops, forgot to shade on the first one. Is it below, since y is less than? So below the dotted line. It's above the blue line, so the overlap is everything in here. All right, I'm take a quick break here, and we'll start. Okay. Oops. Number 14, we're solving this with substitution. Now, I will tell you on the test, please use substitution, but if you're not going to substitution, don't just leave a blank or don't just guess. If you need to use elimination to get the right answer, use it, and I'll maybe count half a point off. Maybe I'll be generous and let you use that one. Just one to use in this situation. combine your like terms. I wrote it down. I get my x is equal to this one, but it doesn't matter. It's fine. 6. Again, I would leave it like that, but you could also put it as an ordered pair. It doesn't make any difference. And this is similar to what we did up on the other page. Number, hold on, let me look at number 6 up here. Oh, no, number 4. Makes me feel better. So I'm going to divide y by itself. So divide by 2, divide by 2, divide by 2. I end up with y is equal to 5x minus 7. Now I can sub that back in for this y. So 3x plus 2 times 3x plus 10. 3x plus 10 is add 14 to both sides. 13x is equal to 26. So x is equal to 2. Once you have that, plug it back in. Y is equal to 5 times 2 minus 7. That is 10 minus 7, which is 3. Okay, moving on then. The bottom, it's easiest to cancel out the y's. You could multiply the top by -2 and cancel your x's. That's fine if that's what you chose. It's a little easier if you multiply the top one by -1 or the bottom one. So you have -2x plus 3y is equal to +3. X 12. This part's a little bit harder with elimination. But plug it back in and solve, doesn't matter which equation you use. My game today. -5, so your answer for this one, what did I mess up on? To be negative. Just the negative. So you end up getting no, -3. Jeez, I'm not catch up here too quickly. 9 divided by -3 is -3. I have to work it right here. I swear it's wrong thing. All right, moving on, number 17. Hopefully this goes smoother. This one you have to multiply both 2, so that gives you -6x minus 18y is equal to 36. My second equation, to get 6x minus 15y is equal to negative 27. Negative 21, sorry. Said the wrong thing, wrote the right thing. X's cancel. Positive 18 plus 15 is positive 3. 21 is 15. Y is equal to 5, and I'll plug that back in. Doesn't matter which equation, so I'm going to use the second one. So we have 2x minus 25 is equal to negative. To both sides. Both sides by 2. X is equal to 9. Y is 5. All right, moving on to the next one. These are the story problems. They give you the variables. You just have to set it up. A brief description. First fruit. First thing is fruit for 30. The next thing is 5 grapefruit for $34. O for oranges, G for the first one. 38. Here. Combination for this one. So negative G is equal to 68. G equal to should be negative 68. 38 minus. I'm just double checking my answer. Can you make sure to make a mistake? Any more mistakes, I should say? 5 by negative 6. Y is equal to positive 5. Sub that back into find your X. Sub it in for your G plus 4 times G is 5. Subtract times 20. is equal to 3. Brief description. I don't have time to write it down. You won't be able to read it anyways, but the brief description is the description. Make sure you see what they ask. How much does fruit cost? My description. Grapefruit were $5 each. The oranges were $2. $3 each. Doesn't have to be anything extravagant. Just get to the point. All right. Number 19. Two Olympic athletes were discussing how many gold medals they've won. They won 14 medals combined. Larry won 2 more than Todd. So L is Larry's medal, T is Todd's. So the first one, when it says combined they won 14, well, this one a lot of people miss, but if you take the number of Larry's medals plus the number of Todd's medals and add those together, that's got to be 14. Well, if L is the number of Larry's, if T is how many Todd won, then L plus T is 14. Then it says Larry won 2 more than Todd. Now this is the hard part. Larry won 2 more than Todd. Does that mean L is equal to T plus 2, or does that mean L plus 2 is equal to T? So again, L is the number that Larry won. T is how many Todd won. Always look at it, but for me, I always say, so if you look at these, both of these, which one's bigger? Is the L bigger or the T bigger? Well, in this first one, the L has to be bigger because T plus 2 is L, so L has to be bigger than T. This one, T would be bigger because L plus 2 is equal to T, so T is 2 more than L. So which one do we want? Do we want the L to be bigger or the T to be bigger? This one says Larry won 2 more than Todd. So Larry won more than Todd, and so that's the one we're looking at. Again, what it means is if Larry won 2 more than Todd, that means if you take the number that Todd won plus 2, that's Larry's. So Todd plus 2. So that's part of your answer, setting up that equation. Now to solve this, I guess I didn't over here. I would use substitution just because it's set up that way. So it's T plus 2 plus T is equal to 14. That's more rigorously. Don't really need the parentheses for this one, so we can drop those. So there's 2T plus 2 is equal to 14. 2T is equal to 14 minus 2 is 12. T is equal to 6. So you have 6. Actually, either of these is pretty easy. If you look, if they won 14 together and Todd won 6, that means Larry also obviously has to win 8. Or Larry won 2 more than Todd, so if Todd won 6, Larry won 8. So a brief description, all I would say is Larry won 8 gold medals, Todd won 6. That'd be crazy. Number 20 says the board's family tickets are $10, adult tickets are $15. $5. Children is how many adults and how many children went to the park. For children, that's the only options. So if you take the number of children plus the number of adults, that has to be 9. $10 child. $15 adult. Let's find the top equation by negative. Minus 10 is 5. 90 is 15. So that means get into this, or just think about it. If there's 3 adults, that must mean there are 6 children. So again, reread what they're asking. How many children and adults went to the park? 3 adults went to the park and 6 children went to the park. So this next one, actually, I'm going to get to this one later.